Hi there. So I'm doing a LeetCode problem every day until I become a software engineer. So the problem that I'm handling is middle of the linked lists. So basically you grab every value after you reach the middle of the list, and then you proceed forward. So in this case, this is 1, 2, 3, 4, 5. You grab only 3, 4, 5. And then if the number happens to be even, then you grab the rightmost middle value. So in this case, you divide in half, 4, 5, 6. So how I tackled this is I first started off with my variables. And so I created an empty list, calling it back. I have a check. So basically, once the program identifies if it's the center, then it would start copying these uh, list items. And then this is just for the calculation process for the index. So finding the index, I make sure that if it's a odd list, then I do this calculation right here. If it's an even list, then I just do this. And I make it go through a loop through the entire list. And then once I reach the index or the center of it, then I will allow the program to start copying the remainder of the list. So in this case, I append the back list, and then I return the outputs, and then here's what happens. Submit. I had problems. Okay, so this was super abstract, so I decided to look up the solution, and now I kind of get it. The First, you start off by setting the slow and the fast, and these are linked lists in the same location, setting it just to whatever the head is, and then the head is like the first position of the linked list. So we basically set up a while loop that checks to see if the uh, existing number or existing linked list and the next linked list exists. And if it does, so if you haven't gotten to the end yet, then you have each the slow and then the fast proceed. So in this case, I have a little picture. To say, for example, we have 5 arrays, or sorry, 5 linked lists. The slow will proceed 1 step at a time, while the fast will proceed 2 steps at a time. And if there's nothing left, then we can assume that we've reached the end of the list. So in this case, we proceed, and by the time that the fast reaches its end, we can also assume that the slow has reached the midpoint because the fast is twice as fast as the slow. And so we can return the slow, which automatically has the middle of the linked list along with the remainder of the linked list. And so we can run it, we could submit it. And yeah, this is a pretty fast speed for the person that I copied off of. This took me approximately 1 hour to solve.